Example 3, a car that normally sells for $20,000 is on sale for $16,000. If the sales tax is 7.5%, what percent of the original price of the car is the final price? All right, so we're talking again, part, percent, and whole. Our part that we would pay would be the sales price. The whole would be the normal price. And our percent is what we are trying to find. So we talked about on a previous problem that to find our percent, we do the part divided by whole. Now, if you didn't already remember this, if we think back to our equation, part equals percent times whole, and you think about how we would solve this equation for this, we would divide by the whole, which is where we come up with this part. All right, so our sale price in the problem is $16,000, and our normal price is $20,000. So to find our percent, we would do 16,000 divided by 20,000. When we do that, we get 0.8. So the percent of the original, or what percent of the original price of the car is the final price, it would be 80%. All right, our next question says find the discount rate. So on this one, we want to think if we pay the entire cost, it would be 100%. But as we found in the last problem, we're only paying 80% of the cost. So if we take out what we are paying, we get left with 20%. So we have a 20% discount rate, meaning that price is 20% off of the original. Our next question on here says, by law, sales tax has to be applied to the discount price. However, would it be better for the consumer if the 7.5% sales tax was calculated before the 20% discount was applied? Why or why not? So we're going to work this two ways. We're going to work this with doing the tax first. I'm going to divide my paper here, and then we're going to do it with the discount first and see if there's a difference. All right, so let's work on our tax first. So when we pay our taxes, we have to pay the entire amount plus the 7.5% sales tax, which when we add these together is 107.5% is what we are paying. So we need to change this into a decimal. So we move our decimal point over 2. So we're going to take the percentage as a decimal, so 1.075, and we're going to times it by the original cost of the car, which was $20,000. When we multiply these, we should get something larger, and we get $21,500. So if we buy this car at the original price and pay the 7.5% sales tax, we would end up paying $21,500. All right, so now let's apply the discount, which was 20%. That's what we found on our last question. So a discount of 20%. So if we have a discount of 20%, that leaves us paying 80%. So if we paid all of it, would be 100 minus the discount. So this is what we are paying of the price. So we're going to do 80% times the cost of the vehicle with the sales tax. So we change this to a decimal, so 0.8 times 21,500, and we get $17,200. All right, let's go over here and let's do the discount first. So for this one, we can use our discount price. So we've already found, let me find my paper here, we've already found that the discount price was $16,000, which was in our problem. So we're going to use that one. So we're still going to pay, we already found the discount, and now we're just going to apply this sales tax piece. So we're going to do the 1.075, so the amount of tax, but we're going to use the discount price of $16,000. And when you multiply this, we get $17,200. So if we look at this, both prices were the same. It didn't matter what order we did these in. And the reason we can do that is because of the commutative property of multiplication. Commutative property allows the multiplication steps to be moved around and you still get the same answer. So we're going to put we get the same answer because multiplication is commutative. All right, so our last question on this problem asks us to write an equation applying the commutative property to support your answer to part C. So we could take the price of the car, times it by the amount of tax, and then times it by the amount that we pay. So this was tax, and this was what we pay, percentage-wise. But we could also flip-flop these, which is what we did on our last problem. So we could do the original price times what we pay. That would give us that $16,000, and then times it by the tax rate, and we get the same answer. So this is our pay percentage and the tax rate.